This presentation was given at an MSCA meeting at SVN on May 25th, 2003. My name is Todd Thuma, and I'm an instructor at Mulberry High School. I teach in the MAT Academy, the Mulberry Academy for Applied Technology. I am completing my 7th year at Mulberry High School and my 8th year of teaching. So I want to just give you a little demographics about our high school. We have approximately 1,300 students, 40% of which are white, 47% Hispanic, and approximately 9% black. 53% are economically disadvantaged. 60% of our students qualify for free and reduced lunch, which means the entire school is free and reduced. We approximately have 61 full-time faculty. That varies year to year based on units that we're allowed to teach. We turn out 20% of our students that are college ready, and our graduation rate this year was 84%. We received Title I funding, and we graduated about 250 students. We have acceleration points or acceleration rate, which in addition to graduation rate and several other factors go into our school grade, which was a C by barely 5 points. We could have been a B if not for those 5 points. But our acceleration point or acceleration rate is one of those things that's calculated based on whether a student does one of 3 different things. They can take an AP college-ready class. They can take a dual enrollment class, which those are really open only to those with the right GPA and above. And then finally, the third thing that a student must accomplish while at high school is an industry certification. And those all speak to our acceleration rate, which is part of our grade at the school. This is just a real quick look at Polk County. Mulberry is in the very southwest corner of the county. We're bordered by Bartow and Fort Meade, and I believe George Jenkins there in the pink on top. Mulberry Academy for Applied Technology combines the automotive, robotics, and engineering programs into an academy. We want to go for NCAC accreditation, which is the National Coalition for Academies. And to achieve that, we need a certain mass of students. Plus, we think that there's a real good synergy between automotive and engineering and robotics. Think of self-parking, self-driving cars. That's kind of automotive and robotics. Automotive manufacturing is engineering and automotive, and of course alternative energy cars like new lithium cars and solar powered cars, those are automotive engineering. And then there's robotics and engineering are kind of hand in hand. Most robotics programs are in the engineering departments at universities. And finally, one thing that I want to point out at the end of the presentation is that we are involved in electric vehicle racing here, and something I left off, we also do robotics competitions. Here's the 3 instructors. I am Mr. Thuma on the left. Mr. Dowdy is in the middle, and then on the right is Mr. Bush. Mr. Dowdy teaches our robotics. Mr. Bush teaches automotive, and I teach engineering. The engineering program is we use the Applied Engineering Technology program from the state. It is a framework or a group of standards that takes 3 years. And the 4th year, if students are able to take the 4th year with me, is a cohort year where they work on projects, engineering-related projects. Our primary responsibility in our frameworks is to teach computer-aided design. That's where our industry certification is. We've been working in SolidWorks, and recently I became certified in Fusion 360, so I'm able to now add Fusion 360. Both of these industry certs, when students pass them, will bring money into the program. It's based on CAPE funding, and currently that CAPE funding is about $350 for a 0.1, and both SolidWorks and Fusion are 0.2, so we bring in about $700 per student, and that money takes a while to get to us. For example, this year I got 17 students through, and I will see that money sometime in April of 2024. In robotics, we teach Inventor, and Mr. Dowdy also became certified in Fusion 360, so he was teaching it at the end of this year. And one other thing I do is I teach the Certified Production Technology Certificate through MSSC, which is the Manufacturing Skills Standards Council. This is an industry group, a body that's gotten together to define the individual skills needed to be labeled a certified production technologist. And this is a 0.5 CAPE funding, and we're with a new building that we moved into a year ago in January. We are ramping up to provide this to our students. This is the Manufacturing Skills Standards Council website, and the 4 areas that I teach in that are safety, production, quality, and maintenance. The trainer you see here is from Amatrol. This is an AC/DC electrical systems trainer. There are 2 levels that we teach with this. The measurement tools on the upper left is also an Amatrol trainer teaching quality. There are also software here. We teach SPC and Six Sigma, and it's pretty robust. Students learn to use calipers and micrometers and understand thousandths and that kind of stuff. Below that is the applied electrical control. Here, it's an older picture. It's missing the Allen Bradley or the Siemens that's on top. Must forgive me. It's one of the 2, and I have the other as a side thing that I've been able to acquire. But we teach mechatronics with that, basically electrical control of mechanical systems. And what you see on the left of that is a pneumatics trainer I have that has kind of the basic setup. I'm trying to teach these students how important pneumatics are. It's a lot of industry is run by pneumatics, and so we use that as our controls before entering the applied electrical control system, and I can teach them about those kinds of valves and isolation and stoppage and stuff. Over on the right is our applied mechanisms trainer, and it teaches all the basics of mechanisms and basic simple machines. One of the things I do start the students off on when I do computer-aided design is they do a little bit of hand drawing. It's not serious. They get a ruler and a pencil and some graph paper, but we're basically teaching them the basics of isometric and orthographic. We teach the front, top, and right, and help them to understand the third angle perspective and what it means by projections and that kind of stuff. Again, we teach SOLIDWORKS, Fusion 360, and Inventor. And Mr. Dowdy's working on his Revit. And during the pandemic, I call it pandemic, but the pandemic, we worked with Tinkercad for those students that were at home. It was a good way of keeping them involved and thinking about these issues. Now with Fusion 360, we're a little bit more capable of doing stuff at home. What do we do after CAD? Because CAD is not it. In my opinion, CAD is just a stepping stone to what I really want my students doing, and that's manufacturing. And besides the CPT stuff, I want them thinking about additive and subtractive manufacturing. I want them to be able to 3D print, and you see our 3D printers there. We have a Delta Maker. We also have a Creality CR10 Max, which is on the right, and we resin 3D print with an Anycubic. We also teach subtractive manufacturing. I have a Wazer, a Roland MDX benchtop mill. We've got a CNC router that's on its way, thanks to a grant, and we're hoping one day to have a laser cutter engraver, hopefully an Epilog or something similar quality that we can cut and raster images onto things. Here are the Wazer. If you don't know what a Wazer is, it's a benchtop water jet cutting system. You might see on top of that a gear and a plaque. I made the plaque, and the gear is one of our reason we got the Wazer is we want to be able to cut our own gears for the electric car racing that we do. And then over on the right is the Roland MDX50. One of the things that's in my frameworks by the state to teach is a socially responsible view of engineering. So we do a recycling unit and talk about the problems associated with that. You see 16 bags of water bottles, and these are all water bottles. They've been selected out of the recycling that's been brought in. We take the caps off the PET bottles because the caps are generally made out of HDPE, and we intend to shred those and use those in an injection molding process, which would give us the ability to teach full cycle, to recycle the product and value it because it does have monetary value, and then to shred all the plastic and then be able to use it into making products. And again, how does that help us with Beyond CAD? Well, the goal is to have students design things and then be able to manufacture, prototype, produce things that they've designed. Over here you see some of my students from the past. Most of these have gone on and graduated, and those are bottle caps that we collected and then sorted. Here's our shredder. We had this built by Fuse Fabrication. It was a design we were able to find with Precious Plastic online, and it's a very simple design. We tried hand cranking. I thought that would be a good experience, and what we learned is you can't hand crank PET or HDPE plastic very well. It was fun though watching high school students struggle with that. What we're doing now is we're going to hook it up to a 110, 220 volt motor that was spec'd for this, and it's going to get attached to a 30-to-1 worm gear reducer, and you can see some of the control systems that we've looked at, and students will be helping me hook all this up, and we'll be getting it on that platform, the steel platform on the left, and we'll be shredding our own plastic. Here are the injection molding machines that we built in class as part of a grant. I was able to write a grant. In fact, I got 2 grants for this, which is why we have so much equipment. I have on the right 2 injection molding systems that are about 1 cubic inch of plastic per shot. And then on the left is a 2 cubic inch shot. And we basically found these on websites and YouTube videos, and we basically followed the directions, but it's a learning process too. We wired it all up. We got things working. We're using PIDs there to control the temperatures. On the right, you see a couple molds, and the top is a blank aluminum mold. The idea was to mill out a design using the Roland, and then we discovered the Roland will not mill aluminum. So we're searching for another benchtop mill, sub $10,000, that would help us mill those aluminum blocks. But we pivoted during the grant. We found these blocks that had cavities in it, and what you can do is you can 3D print in resin with a high temperature resin. You can 3D print a resin that will receive molten plastic, and so we tried that. Students did a design competition, and this was the one that was selected. It was a coin. It's fairly thick. I think it's ½ inch thick from the reliefs all the way through the body of the coin. And the idea was to make these available to seniors who were graduating. Unfortunately, we couldn't get a good shot because it's just so much plastic that has to be pushed through the mold at one time. And that's part of why I want them doing this stuff after CAD. Once they've achieved their CAD skills, this is the practical aspects of it. This is the point where they learn. I mean, oh, it's too thick. It's too much plastic. Maybe it's too big. And we can begin to design things that are reproducible. This is our electric race cars. We have Car 38 has been with us now, I think, 5 years, and it won the high school championships 2 years in a row. Then we had the pandemic, and you can see the team in the upper right there. And this is a frame below that is our second car, Car 100. And these are the students that were working on it. We did this in periodic sessions where they learned to rivet and Claycos and all that kind of stuff. This is the 100 carts. Not 100% finished. We got it running and then spent the season racing it and fixing it and getting it optimized. And now we're going to spend the summer painting it and finishing it out. And then over on the right was the team that I finished with this year. I also do some solar. The idea was we ended up getting 3 solar panels from the Polk County Sheriff's Department donated to us. And I had students design the platform it was going to sit on with the idea that the panels could be swung out when they were outside, leveled against the sun. Eventually, we want to put a linear actuator there that would follow and track the sun. And we can charge up to 4 lead acid batteries there on the platform. We used Unistrut there to put everything together. Students learned to wire it, and we've also researched how best to, you can hook 4 batteries up together in parallel and put the charge cables at one end. But there's some research that says this is problematic for the last battery in the line, and it's problematic for the first battery. So we found a website that showed us how to, in parallel, gang these batteries up and to distribute the charge at best. And so you can see a crazy wiring arrangement here. We actually start the negative on the B battery, and the positive goes to the C battery. And all the cable lengths here are exactly the same length. So there's no bias between one battery and the next. And it sits on a recycled mobility cart. Those big gray wheels underneath is a motor. It's a 24-volt system, and we're looking to get a couple small batteries that could power this and then charge them up too when we're not charging race batteries. But the idea was to take this to a race, and when the 2 cars are done racing the first race, which we race for an hour in Electrothon, and so it's more about battery management than speed. As soon as the race is done, we take the batteries out, put them in this arrangement, and then start charging them using the sun. And we've been able to do this a couple times now, which is great. We are hoping in July of 2024 to compete in Texas at the Solar Car Challenge, which you see here is a car that was built by another team and competed, I believe, in the 2022 season. On top is a solar panel array, and the car is, a reverse trike with a motor in the back. They used a similar motor to what we use in an Electrothon. It's basically a golf cart motor, and they're running a little bit more battery. In Electrothon, we're limited to 1 kilowatt hour of battery. They start with 5.25 kilowatt hours, which is, we think is, we believe we have all the skill necessary to build our own car, add solar panels to it, and a battery array that would allow us to compete and do quite well. So that's what we're planning to do in 2024. I also do a little bit of PLC. I'm looking to ramp this up. I have 2 PLCs on the left, Click PLCs, and on the right is a new one I acquired this year. A bunch of people from Nebraska are working on a kind of a low-cost trainer with all kinds of capabilities. They also will be adding, I believe, a Siemens PLC to this board. So the idea is just to give them the basics of ladder logic and how to wire these systems up. I'm a big proponent of going from design to product, and so I model that for my students. On the left, as you see, a plaque. This is the first time I did this last year for my graduating seniors who had participated in Electrothon of Tampa. I had 4 last year that basically I used the mill to cut out the M on the lower left, and then I filled it in with a resin. This is a bamboo board, by the way. And I belonged to Maker Effects in Orlando, which is a club sort of. It's got a lot of equipment. They have a nice laser up there, and so I was able to laze onto the plaque our racing logo and the words, the text, and then I attached a wrench there because I thought I like this kind of mixed media, multiple things happening. And then on the right, this is the plaque for this year. So I made a coaster, but I must have had a different bamboo because it bled all the resin bled through the veining on the bamboo. Another lesson learned. But so they became coasters that I painted, which I can't paint. So that's another lesson learned. But what we did was we 3D printed a model of the car and spray painted it silver. And I have a couple stickers because I didn't have access to the laser this year. And the black text that you see is actually milled out by the Roland mill. And we were able to accomplish that. And again, it's helping my students understand how you go from the basic design to a finished product. And I'm a big proponent of that. So just a quick timeline of where we've been. This year we've graduated 17 from the engineering program with their CSWA, which is the Certified SolidWorks Associate. This has been our first whole year in the new building. Last year we graduated 19. We certified 19, not all of them graduated, which is why we're a little lower this year. And we only spent half a year in the new building. And 8 the year before that passed CSWA, and that was with 20% of our students learning from home. In 2019 to 2020, which is our first real opportunity to get students certified after 3 years of the engineering program, we got 5 done in the third quarter, and then we never came back from spring break, basically. We left a week early and then never came back, and that disrupted our testing schedule. We could have had a few more in there. Then our second year and first year, and I started Mulberry High School in 2016, 2017, where I taught robotics, and Mr. Young came to me and asked, what did you think about having engineering here? And I said, I think it would be great. And he said, what about you teaching it? So I said I wanted to make certain I was qualified, and I went and got my CPT certification and my SolidWorks certification. So it's something that I'm very proud of, to be able to do those things and bring this to students. So there's our car. This is an old picture from when we did the showcases at the RP Funding Center, and you can see that we were very excited to show off some of the things that we were doing. So please contact me if you have any questions, and we'd love to have companies involved in our advisory council. We really need that support as far as you telling us what you'd like for us to be turning out, what skills you'd like for us to be turning out with students, because ultimately most of them are going to go get jobs. And while I have no problems with students taking jobs at McDonald's and other fast food restaurants, I tell them that's not a successful life. I can turn them out with skills that can earn them more money each year than teachers make. And I tell them that that's my goal for them, that if they're not making more money than me after getting out of high school 3 years later, they should be making more money than me. So thank you for your time.